Hello. This week's environmental systems assignment deals with starting to work on this page for your NAB compliance portfolio. That's what we're calling it. Last week we did HVAC, just the layout and zones. This week we're going to be talking about measurable outcomes of building performance. We have to establish that for NAB that we understand something about measurable outcomes of building performance. Of course, building performance is a fairly vague term. What it typically means is energy use, and so that's the way we're going to interpret it. We are going to be, let's see, we're going to be using the Climate Studio thermal analysis simulation. I already did a video that was shared with you as part of an earlier HVAC assignment near the beginning of the semester. So I'm not going to go over that again. You can review that either by looking at that assignment. There's links in the PDF, I think, or you can find this 25s.A325 HVAC intro in my YouTube channel, which is called NYIT.SAMELAB. Other thing I want to point out is that there's a Climate Studio has a good help page, and I think it's good because it's not just about push this button or this is how you do some specific workflow. It has a lot of background information. So, for example, if I'm looking at how to deal with the with HVAC settings, not only does it talk about the settings, but it has a nice graphic about and describes in detail what your options are. So it's a good thing to use in tandem with the software to learn these principles. And that's kind of the way we're going. We're not so book oriented anymore, but we have things like this, like detailed help sections. So please utilize this resource. All right. So the way that we're going to approach this page, and I'm not going to this week present a template for this. But what we are doing is I'll provide this spreadsheet to you, and this will be part of the final page. What this is all this, whatever that light orange colored cells are presets that you're going to use as everyone's going to start off here, and then you're going to iterate toward to try to improve your performance. There's two ways we can do that. Two categories, and they fit in well with environmental systems because one of them, we have access to passive inputs for things like the building envelope, which insulation is passive. You don't have to put fuel into it for it to work. Air infiltration is passive, and then we can also adjust our mechanical system and do other things with mechanicals like lighting, or with active systems like lighting. So we have access really to the full year of environmental systems with this little exercise. I'm going to use this, the gem charrette that we worked on earlier this semester, just reminding you that it's on a site. I'm not going to use this model. I did a bunch of other simulations here as part of other exercises that and videos I've made for you all. So I'm going to use just the thermal. I'm going to do the thermal analysis just on this simplified model. I will bring in site shading, but one point to make here is if we look back here at this huge site, and if I do a quick solar shading analysis just by kind of scrolling through the year, I determined that really the only surfaces that we're going to shade my building I'm not talking about the trees here, are these. All right, so this is south facing. So there's this building here. It's obviously going to shade these south facing windows. But why would I do this? It's because in the thermal analysis, shading takes a lot of calculation time, and so the more surfaces we have that are shading, the more time it will take. So you could even maybe not do the shading until the end. That may not work though, because you'll see what we're doing here, that we're looking at our outputs and deciding what would be the next most sensible thing to try to fix or improve. And so maybe it's not going to be it'll be, maybe we're going to want to have shading on from the beginning because that's a given. We can't get rid of it or can't change that part. Okay, so just to go over a couple other maybe a little bit of review. Remember that we have, if we go back to this spreadsheet, you see there's space use, construction, and HVAC. So these are the three types of inputs that we're going to have access to in Climate Studio. The way Climate Studio organizes these is in templates, and so we have a space use template, zone construction template, and then we have HVAC, which is in a different tab here. So I'm going to go through these each individually, or I'm going to set up the baseline model, and that will make me go through each of these. Another thing just to mention is that, so I've got all my zones named. These are the thermal zones that you would have created this last week. If I want to edit my settings, so what do I have here? I've got my zones. I've got the window to wall ratio, which should be probably set at 0 for you because you're going to have your own windows like I do. These I've applied these windows. Then I've got a space use template and construction template, and then I can have HVAC in the other tab, like I just said. If I want to edit any of these, so I select all my zones. If I select the icon next to the template, it will bring up this window, and then I can either edit it here to modify it, or I can, you see I've done that already here on the last template I ran, or last run simulation I ran, or I can access the full library and search here. If you ever can't find something that you think you've made, it might be because this is a filter here, so if I put any building type, I have more access to more. So here I am in the space use set of templates, and you'll see down here that I've got some that I made myself. So let me show you how to do that, because I would suggest that you do it for this assignment. If I come here to this library icon and select it, and I'm in zone use templates here. If I select any of, and I come down to the bottom, you'll see that I've got a bunch that I've made for different reasons, and I can edit them. That's the difference. The ones that are provided, I can't edit; they're locked. The ones I make, I can. So I can just select, anything that I want and copy it here. I'm just going to call this test. And we can talk about in more detail in class, and your section leaders or professors can talk to you, or you can ping me if there's something that nobody understands. So I'm not going to go over these things in detail. I will mention that setting this will set your baseline that you're comparing your runs to, which could be useful. Not that important, but anyway, I wrote down that I was a comment that I'm making a NAB SC6 baseline template or something when I made these before. But I'm just going to show you that I say okay now. I already made that I guess earlier, and so now I have test down here. I'm going to go, and then I can edit it. Click here, and then I have access to it, and I can edit it. I'm going to go to my NAB template and edit it. And you'll see that, unless I changed it for some run I was making, all the settings in this template are the same settings as are up here in this spreadsheet I'm going to give you. But you can also just use this video and just, stop it and look at these. So this is what I want you to start with. A certain amount of people per square foot. This is a pretty large number, but you have a theater. So how many? This comes from the occupancy tables in the code, right? So 1 divided by 0.05. This is an occupancy of 20 square feet per person, which is like I think a assembly with no seats, or no, it's more like a classroom. Assembly with seats, I think is 15, maybe, I don't know, whatever. So I just picked something that was fairly high, but not maybe as high as you would need to. And if you were doing this in a really detailed way, you would pick for your theater, you would pick the actual number of people that would be in there, and for the mechanical room, you'd probably have none, right? Right now, I'm leaving everything all on. I have equipment and lighting power density set. Just pick these numbers, and we can. And anybody wants to talk to me about these in detail, I will do it later. Under conditioning, we have a cooling and heating set point, and then we have, this is the amount of mechanical ventilation per person and a minimum that is set. And why is that part of space use? These are all things that are creating heat and using energy. And so if we are bringing in fresh air, we're going to lose some heat or gain some heat when we don't want it, right? Because we're bringing in fresh air from outside, and we're dumping out conditioned air from inside. Okay, so that's our space use, and so now I've got that. You would have created a baseline template. The reason I say to create the baseline is as a template is that then, or all of these as templates, then you can come back to them and reuse them and rerun things. Now I'll go to the zone construction and come down to my template, which is here. Say OK. Oh, I'm sorry. I'm going to edit it so I can show you the inputs. What I've done here is just I'm trying to create something that that will allow us to see the effects of all the different portions of our building. So these are they're not terrible, but they're not great settings in terms of the most efficient. For my envelope, I just set everything at an R of 1, and that's not completely ridiculous. What that means is these are actually default settings in Climate Studio. So if you go in and you were creating this, and we can do this in class together, you just would pick the default construction, and if I click on it, you see that it has an R of less than 1 total because it's all concrete. So what I've done is just make the whole building concrete. That gives me a very low R value. I have set the exterior windows to. I just picked the default, which also is default glazing. Hopefully you remember all these terms. It has very high visible transmittance, 91%, solar heat gain of 90%, so very high, and a very low U value. So it's just a piece of glass. It's not very technically fancy. So that's the baseline, and you have that in both now in the screenshot, but also in the spreadsheet. Okay, so I've set then a baseline for my space use, my construction template. Now I need to do and then I don't know if I actually set those or not, but I would come in here and select. Again, yeah, this is on education for some reason, but no, it's saying it's modified, so I could go here and probably go down and pick it if it was. That's not there, so let me go and pick any building type, like I said, and there it is. Nope, there it is. I select it. Now it's set. I can go and I can do the same thing. Select these again and choose that template for my construction. Actually, I'll do it here. And I have my baseline. Okay, so I've got that set up. Now I'm going to set my HVAC system. The first thing I want you to do, by the way, here in your HVAC is just, we really haven't gone over this, and I'm already at 13 minutes. Okay, the way Climate Studio is set up, and you can read about that here. And again, like I said, it's a book. If I put in ideal air, Climate Studio has created this thing called an ideal air load system, and it's basically, their idea is that they want to make a system that takes out kind of the effect of the HVAC, so it's a perfect system, and that way then you could play around with different fuel types, or just really ignore the HVAC system and work on other things, and then come in and hone on the HVAC system. We're not going to use that for various reasons. So that's the why you have here that there's this thing called ideal air default. We're not going to use it. But then there's 3 other systems that we've talked about somewhat. Here's a VAV system, DOAS with fan coil units, and DOAS with VRF. Just click on each of these and bring them in, like I've done here, to the to make them available to set. your zones for, and then click on the VAV. You're going to, I'll just show you if you edit it. Hopefully you know these terms now. And if these are also in the spreadsheet. The only thing that's not the default is I changed natural gas to coal. Everything else, just if you open up the VAV, they should be the defaults. And I'm going to set all of my, but the point is that there's a bunch of things I can do to change settings in here. And that again, if I go back to my Climate Studio, if I look at VAV, VAV, there's a lot of information here, and we maybe in class I'll talk about this, and maybe your professors will do so too. If not, you can look at it yourself. Okay, so but the point is, for the baseline, I want you to use these settings. Okay, natural ventilation off. And then you come and you assign all of your zones to that VAV system. And what I'm doing there is that's going to be, because of these presets, that's going to be a fairly inefficient system. So we're starting at the bottom and moving up through there. And so then what I did is I ran a number of simulations, but I started with that. So this is my baseline. I came up with a really high number, which I expected. So let's just look at the basic outputs that I want, that we want to use in our NAB compliance portfolio page. The first is site EUI. That is energy use intensity. That's the amount of energy you use, in this case per square foot, and we're doing it with the IP system, so kilobTUs per square foot. Then that gets translated into the amount of carbon used, and the way that works is that different fuel types have different carbon footprints, and we can talk about that in a lot of detail next semester. Right now, let's just kind of leave all those presets. I think that's fine. So if I go back to my outputs here, then I want you to, there's a bunch of awesome things we can look at here. Let me finish this. So that's the site EUI. Operational carbon, that's the carbon footprint. This is, has to do with climate change, has to do with local law 97. There's also an energy cost, which comes from, you can set that in, you can actually go look up these, and I can show you how to do that, but we're not worrying about it right now. The current pricing in our region for these different fuel types. So we have that output. And then we have that baseline thing I was telling you about based on whatever comparative. What this is that the Department of Energy has 16 different baseline building types that they've identified. And then they go out and survey thousands of buildings and organize them in these baseline types. And then they create a baseline energy usage for a type of building, like a school or a hospital. And then in this simulation, we can then access that number for the baseline and compare it. We're not really going to do that. I'm just letting you know that's why it's there. So, but clearly this is a really high number compared to that. So we got a long way to go. I want you to. There's a lot of things we could talk about in here. I'm not going to talk about any of them except for this energy flows chart. This is the way this works. If you haven't heard this spiel, this is a very common, very powerful chart in energy simulation or energy use metrics. So here's how it works. We have 0 in the middle, and then months of the year and different assemblies and components from the building. Like, people give off heat. That's why the people portion of this is always going to be in the gains portion, because we're gaining heat. Then there are lots of ways that we lose heat in that, so for example, in the winter, our envelope, which is this light green, is going to lose heat. When it's cold outside, we're going to be heating inside, and we're going to lose heat to the outside. So that's why this is down here. Infiltration in the winter is going to lose heat. And so what the simulation does is for each month, it says, okay, I've got this many losses, passive losses from infiltration, people, windows, envelope, heat coming off of machinery. And so I've got a deficit. I need more heat, so I'm going to add heat. That's what the red is. And so you see the winter, we always have red to bounce out, and then we get into a place where then we're needing the blue, which is cooling. So our goal is to get rid of as much of the red and the blue as possible, and we do that by analyzing this chart and deciding what we want to work on next. So looking at this right now, I can see that I could probably improve the envelope quite a bit. That's this light green. So I went and went into my templates. These templates that we made. I changed settings. Well, I'm showing this again. It's kind of a waste of time, but and I made another. I made another template. This one is 90.1, which is the energy code. ASHRAE 90.1 is the standard by which they define the energy code, basically. Anyway, the point is, I went in and I improved the envelope. And when I did that, I ran. My point is, you probably would want to then keep. What I would do is keep track of each run you make. You could add column rows in the spreadsheet, or at least say when you get to something where you think, we'll talk about it in class, and if other professors need me to help with that, I can definitely do it. But the point is, we're just trying to improve at this point, right? And try to understand why we're improving, because that's the whole point. So if and always name your simulation so that you have an idea of what you did. So here I'm saying I'm calling the first one I ran was NAB, space, envelope, and VAV. That's my three templates are at my baseline level. Then the first thing I did is I improved the envelope to NYC energy code. So I click on that. And you see I had a really drastic improvement from, like, what was it? These take a little while sometimes. I'm not quite sure. 682 to 493. And the only change, you can see that now that this, our envelope, the light green, is much smaller. And that's because I improved the envelope, added more insulation. Okay, what did I do next? Well, I said I'm going to try to, I think I can get this lighting improved. I think I can get this equipment number down. And I think I can definitely get the people looks really high. So what's up with that? So I went in and I adjusted the, let me just do it as an example. 1.5, so equipment power density, lighting power density, these are terms that may sound a little confusing, but if you think about them, they make sense. It's just basically saying per square foot, how much power are we using on our equipment? Per square foot, how much energy are we using our lighting? And the lower that number is, the better. And actually, 0.7 is a number that's pretty efficient, but doable. So I go through and I change things like that. I think I changed my people because I felt like that was not, whatever. I think I went to 0.2 or 0.02. So it's fewer people. And then when I ran that, I improved again. I think next then I thought, well, look, my infiltration's really bad. So I went and improved infiltration. You may not know what that could be set to, but we can talk about it. The point is just infiltration's leakage through the envelope. So if we cut down on the leakage, we cut down on the heat loss or heat gain at times we don't want it. Anyway, I just kept that process going. Like I found a way to fix the people. There was, well, actually, I'll tell you that. So I kept going, wow, why is this people so high? And I realized that first of all, if this is like, oh my God, this is confusing, this is a lot. You're supposed to be playing around. You're looking at a graphic telling you where the most of the usage is, and you're just going to go try to figure out how to. It's like a little game. I just know more about it, and I'm just trying to do this quickly to show you where I'm going and what the goal is. So it may seem like it's daunting, but it really isn't. If you just get things set up where you can quickly iterate, and you'll be fine. So what I did is I thought, okay, what could be causing it? And then I went and looked at let me just edit one of these. My space use, and I noticed that the people, my occupancy schedule, and that just means whatever the variable is here, it's people, are they always in the space all on? Meaning that means that this heating load from people is there 24 hours a day. Well, that doesn't make sense. And so I went in and I changed it to I think because this is like I'm trying to think of this as a even though mine's a gym, I was thinking of it like, well, you guys were doing a performing arts venue, so I think I picked a lecture hall or something. Um, anyway, I picked a different schedule. Well, I'll just pick one so you can see what happens. If you just pick a different schedule, it changes the name here, um, and then I ran that with the occupancy schedule, and that solved that problem. Right, so that's the process here. Now I can go, well, maybe I can still go back and improve the lighting, or now I can see that my windows would be the next thing to think about. And this looks pretty um, typical, right? I've got gains in the summer, and I don't have that many gains in the winter. So really, shading might help here. And so I have some shading that I added at one point and ran that. But then let's say I did that. I'm just trying to go through it quickly. Then I went and just optimized the glazing, changing the type of glazing and the amount of insulation. Those three variables: the visible transmittance, which isn't important here because that's not about energy, the solar heat gain coefficient, and the U value. And that change was a big help. I went from 161 to 119. And the point is, you just go through this, and eventually I got to the point where I was like, okay, I think I've done all I can with the passive. I could probably come back and improve this air infiltration, but I'm already got pretty good at it's pretty low. So now I'm going to switch to my mechanical system. So what I just did was environmental systems 1, passive last semester. Now I'm moving into, well, there was some active there too. I changed by changing the lighting and the equipment power density. That's getting into active. So you don't need to separate these. I'm just saying it's both semesters. Um, and so now I'm going to start adjusting my HVAC. So the next thing I did was I chose a DOAS with fan coil units. I definitely suggest you go look at these really nice graphics they've got and just look through each of these, make screenshots or whatever. So that the VAV is on one page by itself because it's got a lot of information about a lot of choices you have here. Um, and then if I put in fan coil unit, let's think about, yeah, that works. I've got a good graphic here of the fan coil unit, and then how the VRF, DOAS with VRF, so it's DOAS with fan coil unit, DOAS with VRF, how they're different. Anyway, so I next then went to, I chose the DOAS FCU with fan coil units. Here's I think this is the baseline. So the baseline has a boiler, which has, we talked about COP, and an air-cooled chiller. I ran that, and got a big improvement. So one thing we're seeing here, if we're getting trying to get toward a contemporary level of energy efficiency, we've got to combine passive and active systems, and that's kind of the summary of this year in environmental systems. And then I went further, and I actually changed. I used a ground source heat pump. I'm not going to go into why that's more efficient right now, but I know about it. You don't, but you can learn by trying and talking to us. And then I went and I tried a VRF that actually wasn't as good, and I could explain why. I finally, just in this quick little exercise, I went and optimized the air infiltration again. So I was looking at this, and I was with the fan coil unit heat pump combination. I've got a pretty good. I'm below this baseline but I'm way below where I started. But then I see, well, it seems like I've still got air infiltration that's the highest of any of these passive measures. Can I maybe lower that? I decided I could by looking at the number and using what the information I have. And so I'm going to stop there. I got it down to 76 kilobtu's per square foot per year. And so the point would be that I would somehow in that process And I'm not saying you're going to get all of that done this week or all of this done this week, but I'm saying that then I would have been able to say, okay, in the middle, just using the energy code, which I can show you exactly what that would be, or there's going to be a range. I would get to some value, and then I could then go in and tweak a little bit more and get an improvement from there, and then I would have this summary output here in the spreadsheet where I could compare these. And that's obviously going to be a very good, in terms of our NAB portfolio, if we can say we started with a baseline, all of us, and this is where my building got to using my knowledge about passive and active systems. That's going to be pretty cool. And then what I'm thinking is that we will output a baseline and an optimized energy flow chart, and then have graphic input, circling lighting, power density, and pointing at something, circling envelope, and just annotate it. I think that's what the final page will be. All right. So that's a whirlwind tour. I think that's all I need to do to get you guys started. I will share this spreadsheet with these baselines. You'll have this video, you'll have the other video, and you have the Climate Studio Docs website. I will see you in class, or somebody will see you in class to start working on this. All right. Bye.